So we're now going to look at yet another case study that's going to illustrate some different capabilities than the stuff we've been looking at so far. So far, we've been focusing primarily on flux operations and how they work in reactive programming. Now we're going to focus on a case study that's going to give us a chance to show some of the mono capabilities. We haven't talked nearly as much in this class about monos as we have about fluxes, but they're also quite interesting. And the particular example we're going to look at here is going to be a case study program, which you can get at the link at the bottom of the slide, that will crawl a hierarchical folder structure recursively and basically get images and count the number of images it encounters during that crawl. And it can either crawl a file system on your local machine, and/or it can crawl a website. So it can be a web crawler, or it can crawl something that's your file system. They're both recursively defined folder structures. And in addition, we're going to talk about some operators from both fluxes and monos that are a little different from things we've talked about before. So let's take a look at the overall approach. As I mentioned, we crawl a hierarchy of folders recursively, which means we start at some root, and then we visit each of the elements reachable from that root, which would be an HTML file. And in that HTML file will either be actual hrefs that refer to images, or they will be hrefs that visit other folders, so we have to descend through the hierarchy. As I said before, the root folder can either be local in the file system, or it can be accessed remotely from the web. Doesn't matter. Our code, as you'll see, is very clearly defined to not care where things come from. And when we do this, here are some examples of the results we get. So as it descends through the hierarchy, whenever it reaches kind of the end of something, it reaches the end of a path, which is basically a folder or subfolder that has no further folders or subfolders underneath it, then it'll go ahead and indicate how many images it counted at that level. And then as it pops up out of the recursion, it'll aggregate the results until we reach the top, where it'll give us the total number of images that we reached. So in this case, giving a link to my website, which at the time had 21 images that were available from that website. Some other things to note: you can put a limit on how far you want it to descend in the hierarchy. And the reason for doing that, of course, is because if you don't do that and you have cycles in your graph, which you can certainly do with websites, you can have a website that links to a website that links back to the first website. We don't want to infinitely recurse. We can basically have a max depth. So if you go deeper than the max depth, you'll get not an error per se, but just it'll stop going that far. And the other thing we can do is, if you've got duplicates in your file system, either because you've got links, symbolic links of some kind, or because your HTML files have duplicate links, if you find you've seen the same link more than once, it only counts it one time. So if it doesn't double count things. And we'll show a really cool way to do that using a feature that's part of modern Java that's called a hash set, or a content view. All right, so that's basically how things work. Let's kind of talk a little bit about how things are designed. So there's a class that's called the image counter class, and it's got about a half dozen methods that we're going to look at, and this is what they look like. And of course, this is all generated using Java docs. So you can generate documentation that looks just like the code you get out of Java, the Java core libraries. And you'll see we'll talk about each of these methods. The entry point is, I believe, count pages async. That's kind of where things get started. Or maybe that's, I take it back. It's count images is the entry point. And you'll see how the images, the methods here are actually called in a recursive fashion because we're traversing recursive hierarchies. We're also going to talk about lots of different Project Reactor operators, both fluxes and monos. And here are some of the ones we really haven't talked about before, like, actually we haven't talked a lot about many mono operators. A lot of them are very similar to flux operators, but here are some interesting ones: defaultIfEmpty and transformDeferred. And then we'll talk about some flux operators that we use as well, especially when we're recursing through this thing. It's really cool. So let's talk briefly first about the defaultIfEmpty operator. So what it'll do is, if you have a mono that doesn't actually emit anything because whatever it was dealing with was empty, for example. For example, let's say you reached a certain level in your traversal hierarchy and there were no more subfolders beneath you. Well, in that case, you're going to get back an empty result because there is, in fact, nothing there to traverse. So in that case, you get back an empty mono. And what we do here is we have a method called defaultIfEmpty, which says if there was nothing there, emit this default value rather than throwing an exception. And what we're going to do there is use the default value to say when we reach the end of the recursion, return 0, because there's nothing there. So again, it returns a mono that either emits the value that was emitted or the default if there was no value emitted from the mono. And here's a great example. This is exactly what we do. We end up iterating through all the hrefs on a given HTML page, and we're going to visit them recursively if there are any hrefs to visit. But if there are no hrefs to visit, we return 0. So if we do this and there's nothing here, we'd give a 0 value back. So if there are no embedded images on an HTML page, we give back a sensible value as opposed to crashing. This is very similar to some other things that you might see if you play around with Java, like the optional class and its or-else method. And there's a couple different variations of or-else, and this is one that is very much like defaultIfEmpty. There's also an interesting schedulers method called fromExecutor. Most of the time thus far we've talked about using schedulers that are things like parallel or bounded elastic and so on, which are Project Reactor-centric pools of threads. But there's also a way to take existing Java pools and connect them or integrate them into RxJava. Or sorry, RxJava, Project Reactor. So in this case, we're going to take an executor from Java's world, not Project Reactor or RxJava, and make it be used to schedule the asynchronous operations. And there's a bunch of thread pools that come out of the box with Java. You get a cache thread pool, which is a variable size thread pool where the threads are created on demand. We have a fixed size thread pool where you pre-allocate the max threads at the beginning and just live with it. And then we have this thing called the work stealing thread pool, which, as the name implies, is very clever, and it steals threads, and it can expand and contract a little bit as needed. It's very much like bounded elastic, by the way. Here's how we do this. So we have a little helper method called commonPoolMono, and you can see what commonPoolMono does is it takes whatever it's passed, which is a mono of some kind, and it subscribes that mono, and we want that to run on the common fork join pool. So we get the common fork join pool, we integrate that in with the reactor, Project Reactor schedulers, and that mono will then run in that thread pool. The last operator we'll talk about here briefly, it was very interesting. This also works for both monos and fluxes. It's called transformDeferred. And what it does, it's kind of hard to understand when you're read the description, but when you see it in action, it's very useful and very cool. It defers the transformation of this mono to generate a target monotype. What the heck does that mean? Well, what that means is that it'll lazily map the mono onto a target publisher instance. What does that mean? What it means is we can define custom operators and insert them into a pipeline of operators that are part of a mono stream, just like a flux stream, or a chain is maybe a better word for mono, so a mono pipeline. So what you can see we're doing here is we're saying, go ahead and get me an HTML page. That's what this stuff up here in black is doing. And we're saying, and do this, get me this web page using the common pool that we get from the Reactor Utils commonPoolMono. This is a custom method that I wrote that you don't get out of the box. And transformDeferred is saying, it's almost like saying, here's a way to add new operators into this pipeline. There's a whole pile of operators that already exist, but if there's not one that does what you want, you have a way of customizing its behavior. So this is essentially implementing the good old decorator pattern from the Gang of Four book, and we're using that to decorate things so that they flow through the pipeline in a more intuitive way. So the transformation will occur for each of the subscribers, and you can have basically a different operator chain for each subscription. And in this particular case, we could actually set things up in a very cool way to decide at runtime whether or not we want to do the processing concurrently or sequentially. So it's very, very dynamic, very lazy, and so that's another way we can do that. So I have another helper method called commonPoolMonoIf, which based on the parameter up here, it's a Boolean, it will decide whether to run this concurrently or not. Here's how that might work. You can say if the parameter is true, then return commonPoolMono, Otherwise, just return the mono without transforming it and making it run in another thread. There's an operator in RxJava called compose that is very similar to transformDeferred. So that's the end of the first part of our case today. We didn't really look at any code here. I just gave you some of the, or didn't look at much code. We looked more at how the project was structured, what it does, and then some of the methods we're about to look at in more detail.